Okay, well, let's dig in, find out here. So, number one, well, I think if you got it wrong, you know what's going on here, right? Although I was surprised, there was more mistakes than I anticipated. When a curve in the road is banked, the component of the normal force contributes to the centrifugal force. That is true. For an object traveling with uniform circular motion, its instantaneous velocity is always directed tangent to the circle. There was lots of people that skirted around the word tangent and didn't say it, and I had to use my judgment to figure out exactly what you're trying to say. The word tangent is the word you're looking for. Sometimes, I think there was maybe the odd person that I gave a half mark to because I was like, well, it kind of sounds like we know what you're talking about. Number three, the centrifugal force is always directed radially inward towards the center. 4 is true. 5 is true. Number 6, straightforward application of one of those small formulas, and it's D, right? 0.64, and I think quite a few people got that one. Oh yeah, so you got to go with the diameter. It's almost a two-step question, isn't it? Right? Is it a two-step, Chris? For number 6? I think it is, right? Yeah. And to be perfectly honest, that's terrible sort of assessment, like practices, but that's the kind of stuff you're going to see in university, is those two-step kind of questions that if you make a mistake, it's going to be wrong. Okay, so I mean, that's the only one on there, right? So it's just a warm-up. They can put the phone away. Number 7, in the flying pig, we discussed the tension in the string. It was determined that the centripetal force holding the pig in UCM was less than. B, the tension is the greatest because it's the hypotenuse, right? Hypotenuse is always bigger, so it's B. Number 8. Okay, you know what? Special one-time deal only. Because I'm taking in the test right now, it was clear to me that number 8 was a very confusing question for people. It was worded poorly, so I'm giving you a one-time only chance to redo number 8 right now. No talking to your neighbor. No looking at someone that got it right, like Joey's pushing over his test to Emily so she can look at it. Okay, you got a one-time chance. This is a top-down circle. You're looking from the top. This is a horizontal. This is me doing this. This is me doing this. Okay, and you are up above in the upper gym looking down. And all I want is the direction of the velocity and the direction of the acceleration. That's all I want. And they should be starting from that circle there, the ball. If you've got less than 2, I'm going to give you a chance to redo that question because I didn't like the way I worded the question. There's no doubt about it, number 9 is a challenging question. Let's investigate. A 1.5 gram insect rests on a compact disc at a distance of 2.5 centimeters from the center. The disc rate of rotation varies from 4.4 to 5.9 hertz in order to maintain a constant data sampling rate. Bunch of mumbo jumbo, but what they're saying is this, is that the frequency, the speed speeds up and changes. So this frequency is sometimes 4.4 and it's sometimes 5.9 or something in between. Okay? Question number 1, determine the minimum or smallest period of rotation. The smallest period is when it's going the fastest or slowest? Smallest period is when it's going the fastest, which is the higher frequency. Now, if you still are not sure, what's the easiest way to solve a question like this? Find them both, 1 over 4.4 and 1 over 5.9, and you will find that this one is 0.23 and this one is 0.17, which is why I put the word smallest period of rotation there. I agree it's a bit of a, but certainly within your capabilities, I think, right? Let's look at B. Okay, now B, what is the insect's minimum centripetal acceleration during its rotation on the disk? The smallest centripetal acceleration is when it is going the slowest speed. The slowest speed is when the period is at its maximum. So it's this number that goes down here. And this always causes me grief. I always have to be very careful when I mark this. I'm really not convinced that I should have this question on here anymore, but the way it is today. Okay? You got to be thinking here. So it's at the slowest speed, so I went with A equals 4 pi squared r all over t squared. And actually, I was pleasantly surprised that a good number of people, in fact, I'd say probably 75% of you got this one right. I got 19.1 meters per second squared. Some people did it in 2 steps. That's not required. They went v squared over r. You got to find the v first. Okay, make sure you can use this one here as well. So that was only worth 1. Now C. C is the tricky one, a little bit, right? So you need to find the centripetal force, mv squared over r. Right? Or I realized last night when I was doing this, I was like, oh, hey, I already got the acceleration. It's just Fc is equal to mac. So that's going to be 0.0014 times that acceleration of 19.1. And you get centripetal force of 0.0268. And that is provided by the friction force, which is equal to mu mg. And some of you did the cancellation thing that I saw, which I thought was really nice. I was pleased to see that. So you solve for mu. And you get a mu value of 1.95. And there's 2 marks for that. And a good number of people got that. There were some rounding errors, and there was a few little mistakes kind of thing. But for the most part, the concept of the centripetal force being provided by the friction force as a whole, as an entire group, I think that you got. If I had to give you a mark out of 4, I'd probably give you as a group 3.5 out of 4. I think you did okay. Now, here's the thinking part. This is the minimum value, the minimum required value to prevent it from slipping. In other words, if friction coefficient is 1.95 or greater, the bud stays on the record. Is it going to be 1.95? No. This is not the actual coefficient of friction. This is the minimum value that would prevent. And so, how likely is the bug to stay on the record? Not very at all. How come? Because friction is likely much less. Oh, do I? Oh yeah, 0.0014. Yeah, I think I just missed one here. You're right. The number's right. I was surprised too, actually, it was that high. Thank you, Kate. The 1.95 is right there. Does that make sense? That this is the minimum required coefficient? Does that, yeah? Yeah, good? Peyton, please.
I'm calculating.
Really? Okay. Does that make sense? Am I good? Yeah? There was actually a lot of people that said that they got D. I was pleased. Number 10. This is a vertical circle question. Lots of people made A way harder than it needed to be. It's just V equals square root RG. Oh, I remember what the most common mistake was here, and you're going to kick yourself when you see what you did. 0.7 times 9.8. And there was at least 3 or 4 people that forgot to square root? Okay? And the free body diagram was another one of those thrown in things, and to be perfectly honest, I didn't look too closely at them, but they had to be kinda at least sort of right. The minimum speed, the free body diagram, in other words, what's the free body diagram look like at the top? Yeah. Because what is the force that provides the centripetal force at the top? There is no tension in the string, right? This is the minimum speed. The minimum speed occurs when the tension in the string is 0. I'll make you a one-time deal. I've already given you the answer for 10A free body diagram. I will come around and we'll redo 10B right now. It's like early Christmas. No. Just the free body diagram for 10B. It's like reverse Ukrainian Christmas. It comes early. So we've got 4.6 times that velocity, 2.62 squared over r, mass times gravity, 4.6 times 9.8, and you get 45 plus 45. A little bit of rounding there, but basically it's 45 plus 45, or 90. And it makes sense that those 45 should be the same. How come? Because at the top, there's no mg, right? The 45 doesn't exist, right? And the tension of the string is just 0. Sorry, this one's 0, and so it's just 45. Okay, draw me a free body diagram for the bottom of the vertical circle. What I'm looking for is very similar to that one that I gave you in the sample questions with the strings. In fact, it's identical, right? So at the bottom, you've got the weight force down, and you've also got, technically it's a tension, right? A lot of people just label it FC, but technically it's the tension that's up. That's all I want, is the force is acting on it. I had a few people that were drawing in acceleration velocity. Not on a free body diagram. You're only showing me the forces. So weight force down, tension force up. That's all I need. Let's see if there's any more Christmas presents in the future. Maximum speed, the 1,1320 kilogram cart can round a turn, blah, blah, blah. The coefficient of friction between the tires of the road is 0.49. Okay, so basically, we need to find the friction force. This is another one of those ones that could cancel out if you wish to do it that way. So the coefficient of friction is 0.49, 1320, 9.8. You get 6,338.64 newtons, and that is what supplies the centripetal force. Mass of 1320, v squared, 87, 87. V is 20.4, make sure you square root. And again, I added on an extra mark. I think it was Joey that asked, should it be in kilometers per hour? And yeah, it should be. And no, it's 1, 2, 3. Yeah. The third mark was for that, but it was Joey that asked, right? Because it doesn't specifically say that, so. Is there anyone that missed the instruction yesterday on that about converting? Don't think so. I think I made it pretty clear. Again, that's another one of those examples where I'm trying to throw on a few extra marks on there to reduce the error weight. Same thing in number 12. I did the same thing. It's a conversion backwards. 200 divided by 3.6. I made it at 2. I threw in an extra mark for dividing by 3.6, which is generous. And then it's just tan theta is v squared over rg, and you're solving for r. 55.6 squared all over 9.8 tan 24. You must use brackets on the bottom there. You must. You must do that. You've got to learn how to do that. 707.4. If you made this mistake, come and see me. You've got to use brackets. Otherwise, you're only dividing by 9.8, and then you're multiplying by tan 4. You must use brackets, or you must figure out what that number is, write it in, and then divide by the full number. Lots of details. The details matter. They certainly did when NASA sent the rover to Mars and forgot to tell the Europeans, oh yeah, we're working in feet here. Mattered to the tune of about $2 billion. 13. This is a vertical roller coaster. V equals square root RG. 11.46 square root 9.8 times the radius. Square both sides. It was the math that was causing grief here. Square both sides. 11.46 squared is equal to 9.8 R is going to be 11.46 squared over 9.8. 13.4 meters.
I got it right.
Did you? The speed is 75. The centripetal force, mv squared over r. 3 times 9.8. Mass is 56.5. Oh, okay. So why do you have to go 3 times 9.8? Because it's 3 Gs. 3 Gs of force. 3 times 9.8. Times 75 squared. You're solving for R. Oh, what did I do? No. Slow down, Bennett. I made this mistake last night. And I got some crazy number like 10,000 meters. And I was like, hold on here, this doesn't make sense. 10,000 meters? What am I trying to do? I'm asking for the 3 Gs. Here's my mistake that I made, right? I went 3 times 9.8. Is that the centripetal force? No, that's the centripetal acceleration. So what I didn't do last night was do that. All this is wrong, isn't it? And here I am looking foolish. Really, it's A equals V squared over R, right? So there's your 3 times 9.8, 75 squared over R, and you get a much more reasonable 191.3 meters, right? Okay, now here's the kind of the tricky part. It should be, 3 times 9.8 should get you another mark. So if you get to here, you should have 3. If you get 191, you should get 3. And then you have to, now here's the tricky part here. It's like that one in the book there, Chris, right, where you have to add the G, and this is, you added the G on early. It's because, right, here's the person, right, the centripetal acceleration is 3g, but the overall applied force, you have to overcome weight force, right? So the net result is 3g, but you need another g just to hold you in air without falling, kind of, right? So I just wrote it like this: ma plus mg. So the mass of the person is 56.5. The acceleration is 29.4 plus another 56.5 times 9.8. 2214.8 newtons. You have to have one more G of additional force just to hold you in the air. So I agree that last question is kind of stinky, the last part, but 3 marks there. And I think a lot of people got 191. I think it was like well over 2/3. Wasn't too many people that missed that. If you have 191, you didn't get 3, then call me over. Okay, so the whole thing is now out of 30. I've given you 2 extra bonus things. Hand them back in, I'll fix them all up, and I'll get them back to you tomorrow.